Schrodinger's time independent wave equation. According to this, its material particle behavior we can study with this equation. A system of stationary waves associated with the particle, okay, you consider, then xyz be the coordinates of the particle, psi the wave displacement for the de Broglie at any time t, then psi is wave function. Okay, it is assumed that psi is finite single valued and periodic function. The classical differential equation of wave motion is given by dou square psi by dou t square, which is equal to v square dou square psi by dou x square plus dou square psi by dou y square plus dou square psi by dou z square, that is equal to v square delta square psi. Okay, where delta square is equal to dou square by dou x square, dou square by dou y square plus dou square by dou z square. Here v is wave velocity. Delta square it is Laplacian operator. The solution for the above equation, it is given by psi is equal to psi naught sin omega t. Then psi naught sin 2 pi nu t. Omega is 2 pi nu. Nu is frequency of the stationary wave associated with particle. Differentiating equation to this equation, we get twice we try to differentiate. Dou psi by dou t is equal to dou psi by dou t is equal to psi naught 2 pi nu into sin 2 pi nu t derivation. Sin 2 pi nu t derivation will be cos 2 pi nu t. Okay, then if you differentiate further, what you get? Dou square psi by dou t square, that is equal to minus sin of 2 pi nu square into sin 2 pi nu t. Okay. Then dou square psi by dou t square is equal to 4 pi square nu square psi. That is equal to 4 pi square nu square psi by delta square, lambda square. Because v is equal to nu is v is equal to v by lambda. It's nu actually frequency v by lambda. Substituting the value of dou square psi by dou t square from equation 3 in equation 1, what we get? V square del square psi is equal to minus 4 pi square v square psi by lambda square. Then del square psi is equal to minus 4 pi square by lambda square into psi. V square cancels out. Then del square psi plus 4 pi square by lambda square into psi is equal to 0. From de Broglie relation, lambda is equal to h by mv. That is equal to h by p also. So del square psi plus 4 pi square by lambda square into psi. So wherever lambda is there, you substitute h by mv. So delta square, lambda square, here you write h square by m square v square. If you send it up, what you get? Del square psi plus 4 pi square by h square into m square v square psi by m square v square into psi is equal to 0. If E and V be the total and potential energies of the particle, E is total energy of the particle, V is potential energy of the particle. Then its kinetic energy is given by half mv square, which is equal to E minus V. Total energy minus potential energy, you get kinetic energy. Then m square v square is equal to 2m into E minus V. From equations 5 and 6, del square psi plus 4 pi square by h square into 2m into E minus V into psi is equal to 0. Del square psi plus 8 pi square m by h square into E minus V into psi is equal to 0. Substituting, okay, this is actually Schrodinger's time independent wave equation. Instead of h by 2 pi, you write h bar, okay, or h cut in the equation. The equation will be written as del square psi.
Attendance needs for that.
So if you substitute h by 2 pi, okay, with h bar, then what you get? Del square psi plus 2 by 2m by h bar square into E minus V into psi is equal to 0. For a free particle, V is equal to 0. Hence, the Schrodinger wave equation for a free particle can be expressed as del square psi plus 2me by h bar square is equal to 0. This is called Schrodinger's time independent wave equation. Okay. Students, could you see here what I am sharing? So we will be deriving, energy levels for a particle enclosed in one-dimensional potential box of infinite height. Okay, A and B are constants. The values of these constants can be, obtained by applying the boundary conditions of the problem. Here, particle is enclosed between two rigid walls, and we know that, particle is enclosed between two rigid walls. Okay, and we know that psi square represents the probability of finding the particle at that instant. Okay, the particle cannot penetrate the walls. Hence, psi is equal to 0. Psi is equal to 0 at x is equal to 0 and x is equal to a. These are boundary conditions. Okay. So, then 0 is equal to psi is equal to what we can write? 0 is equal to a sine 0 plus b cos 0 we can write. Okay, that is b is equal to 0 in this one. So, psi of x is equal to a sine kx. Again, v is equal to 0. V is equal to 0 between the walls. So, this equation becomes d square psi by dx square plus 8 pi square m by h square into e psi is equal to 0. 8 pi square m by h square into e is equal to k square. Then what happens to this equation? D square psi by dx square plus k square psi is equal to 0. The solution for this equation is in the form of sin kx or cos kx. So, solution can be given by psi of x is equal to a sin kx, okay, plus b cos kx. So, a and b are constants. The values of these constants can be obtained by applying the boundary conditions of the problem. Here, the particle is enclosed between two rigid walls, and we know that psi square represents the probability of finding the particle at any instant. The particle cannot penetrate the walls, hence what will happen? Psi is equal to 0 at x is equal to 0 and psi is equal to 0 at x is equal to a. These are boundary conditions. So then if you substitute everything, 0 is equal to a sine 0 plus b cos 0. B is equal, and then what we get? B is equal to 0. Psi of x is equal to a sine kx. Again, 0 is equal to a sine ka and 0 is equal to a sine k. Psi of x is equal to 0 when x is equal to a. Hence, either a should be 0 or sin ka should be 0. But a is not 0 because if a is 0, the entire function will be 0 as b is 0. We already derived that b is 0. So, a cannot be 0. If at all a also becomes 0, the entire function is not valid. Everything will become 0. So, sin ka is equal to 0. In that case, Either sin Ka should be 0 or A should be 0. So that's why we considered sin Ka as 0 or Ka is equal to n pi. Sin pi is equal to 0, right? So Ka can be n pi. N can take values like 0, 1, 2, 3 and so on. K is equal to n pi by A. Now the wave function becomes psi of x is equal to A sin kx, right? K means n pi by A. Sin n pi by A x. From equation 5, this equation, K is equal to n pi by A. K square is equal to n square pi square by A square. K square for, and we have used K square for 8 pi square me by h square. Here, K square we assume like this, 8 pi square me by h square. So, we know K square. What is K square? Now, you substitute this one with this one. So, you equate both. K is equal to n square pi square by a square, which is equal to earlier assumption 8 pi square en by h square. Okay. Then 8 e divided by h square is equal to n square by a square, because pi square cancels out. Instead of e, we are writing n in general. So en is equal to n square h square by 8 a square m. So en is equal to n square h square by 8 m a square, which is equal to n square into 4 pi square h bar square by 8m a square. H bar is h by 2 pi. Already told you, this is called reduced Planck's constant. H bar is reduced Planck's constant, which is h by 2 pi. Then h is equal to 2 pi h bar. In this equation, if you substitute, En is equal to n square pi square h bar square by 2m a square we get. It is clear from the expression